Bismillahirrahmanirrahim. Welcome to lecture number 12 of the course CS 325. We will discuss plotting in Python. So this is the discussion agenda. We will discuss Matplotlib, its architecture, its backend, and the layers. Then we will discuss basic plotting in Matplotlib. Then we discuss scatter plot and line plot and some more plots if we get time. Otherwise we will continue this discussion in next lecture. So let's go to our Jupyter notebook and see the code. Okay, so this is Jupyter notebook where we have to discuss Matplotlib. You can show Matplotlib figures directly in the notebook by using Matplotlib notebook, and you can use Matplotlib inline magic commands. The IPython magics are just helper functions which set up the environment so that the web-based rendering can be enabled. So let's try to execute this code. Nothing happens, but it allows the figures to be rendered in the web, because this is the web browser that we are using. Now, layers in Matplotlib. Matplotlib has two layers. Backend layer, which knows about how low-level graphics routine it can render to the screen or to a file. We will use the inline backend for most of our work. And the artist layer, which describes primitives, collections, and containers. It knows how figures are composed of subfigures and where objects are in a given axis coordinate system. So the backend is an abstraction layer which knows how to interact with the operating environment, whether it's an operating system or an environment like the browser, and knows how to render Matplotlib commands. There is number of different interactive backends, but there are also backends called hard copy backends, which support rendering to graphics formats like scalable vector graphics, SVGs or PNGs. So we import Matplotlib as MPL, import Matplotlib as MPL, and we get the backend. So mpl.get backend, and it will return us. Let's try to clear all the cells. Okay, so let's go and execute this command first, and then this command, and it's nbagg. So this is the backend layer. There is one artist layer. The artist layer is an abstraction around drawing and layout primitives. The root of visuals is a set of containers which include a figure object with one or more subplots, each with a series of one or more axes. The artist layer also contains primitives and collections. These are base drawing items, things like a rectangle, ellipse, or a line, and collections of items such as a path, which might capture many lines together into a polygon shape. Collections are easy to recognize as their name tends to end in a word collection. So this is the artist layer, and these are different page, figure, legend, and a lot of information is given. You can go through the hierarchical structure and try to understand what are the different functionalities that are offered at this layer. And there is one scripting layer. This layer helps simplify and speed up our interaction with the environment in order to build plots quickly. The scripting layer used here is a PyPlot. This is what we most of the time are using, PyPlot. The rest of the things, the backend layer and the artist layer, this is not something that we usually use. So procedural and descriptive libraries. The PyPlot scripting layer is a procedural method for building a visualization. In that, we tell the underlying software which drawing actions we want it to take in order to render our data. There are also declarative methods for visualizing data. HTML is a great example of this. Instead of issuing command after command to the backend rendering agent, which is the browser with HTML, HTML documents are formatted as model of relationship in a document, often called the DOM or document object model. There are two fundamentally different ways of creating and representing graphical interfaces. Basic plotting in Matplotlib. Let's import Pyplotlib scripting layer as PLT. All the functions which we will run against the PyPlot module are part of the scripting layer of the architecture. So import matplotlib.pyplot as plot, and we can see the code, the description of plot. So this is the function and the arguments it take and the description of all the arguments. Because the default is a line style, nothing will be shown if you only pass in 1.32. So plot plt.plot32, nothing is shown. Here we see that the first object is aligned to the object. The third argument in the plot function should be a string, which signifies how we want that data point to be rendered. We can pass in a dot to plt.plot to indicate that we want the point 32 to be indicated with a marker dot. I don't know why it is not displaying. Maybe we have to do plot.show. Oh yes, it's given here. Before, when we do like this 3.2, nothing displayed, you see, and then when we do the plot.plot 3.2 dot, and then the dot is displayed here at position 3.2. Let's see that a dot appears in the plot above. Let's see how to make a plot without using the scripting layer. It's a bit more verbose. This is often referred as Matplotlib Object API, but it can be thought of as directly interfering with the artist layer instead. So first, Let's see the backend without using mpl.use from the scripting layer. So from matplotlib.backends.backend.agg, import figure canvas agg, import figure object matplotlib.figure, import figure. We create a new figure, fig is equal to figure. We associate figure with the backend, so canvas figure canvas agg fig. Add a subplot to the fig. The return value of the subplot is the axis object, so x is equal to fig.addPlot 111. Now plot the point 32, x.plot 32 3, 2 and dot. Now the backend that we are using, the one for the Jupyter Notebook, isn't able to render since it expects the scripting layer PyPlot to have created all of the objects. So save the figure to test.png. We can see by executing this command, canvas.print png, and this test.png will be saved in this location. I think it's assignment 2. Yes, test.png, and you see a dot is displayed. So you see how complicated it can be. We can use the HTML to load this figure. We create a new figure, plot.figure, and plot the point 32 using the circle marker. Plot.plot 320. Get the current axis, plot.gca. Set axis properties. This indicates x min, this indicates x max, this indicates y min, and this indicates y max. Since we are doing this with the scripting layer, once we run the Jupyter cell, it render to the NB-AGG backend. So let's see. You see a dot is displayed. Now create a new figure, plot.figure, and plot the point 1.5, 1.5 using the circle marker. Plot the point 2.2 using the circle marker, and plot the point 2.5 using the circle marker, and let's execute it. You see these 3 different dots are displayed. We can get the current axis, plot.gca with the x, and get all the child objects the axis contains. So you see these are all the children. Here we can see that there is actually 3 line 2D objects contained in this axis. These are our data points. The number of spines, which are actual rendering of the border of the frame, including tick markers, 2 axis object, and a bunch of tags, which are the labels for the chart. There is even a rectangle, which is the background of the axis. There are 2 basic things to keep in mind. PyPlot is going to retrieve the current figure with the function GCF, and then get the current axis with the function GCA. PyPlot just mirrors the API of the axis objects, so you can call the plot function against the PyPlot module, but this is calling the axis plot functions underneath, so be aware. Finally, the function declaration from most of the functions in matplotlib end with an open set of keyword arguments. Now let's try to understand scatter plots. So let's create a NumPy array, import NumPy as np. We create an array, np.array 1 2 3 4 5 6 7 8, and we say y is, so x is 1 to 8 and y is 1 to 8, and we do plot.figure and plot.scatter xy. It is similar to plot.plot xy dot, but the underlying child object in the axis are not line 2D. You see? So we have on the x-axis and the y-axis from 1 to 8. We create NumPy as np and create an array 1 to 8 and y equal to x. We create a list of colors for each point to have, for example, green or red. So color is equal to green multiplied by length of x minus 1, and colors dot append red, and we do plot.figure and plot.scatter xy. S is equal to 100 and C is equal to colors. You see all these are slightly different values in green and one is red. Recalling zip methods. Zip method takes a number of iterable and creates tuples out of them, matching elements based on index. So convert the toList into a list of pairwise tuples. So zip generator is equal to zip 1 to 5 and 6 to 10. These are toList. We print list zip generator. It will print like 1 6 2 7 3 8 4 9 and 5 10. We have another zip generator with a zip, and the single star unpacks a collection into positional argument. So print zip generator, and it will print the same 1 6 2 7 3 8 4 9 and 5 10. We can use zip to convert 5 tuples with 2 elements each to 2 tuples with 5 elements each. So print list zip 1 6 2 7 3 8 4 9 5 10. So it will print like this 1 2 3 4 5 and then 6 7 8 9 10. We can have the zip generator zip 1 2 3 to 5 and 6 to 10, and let's turn the data back into two lists. So xy zip star zip generator. This is like calling zip 1 6 2 7 3 8 4 9 and 5 10. We can print x and print y, and it will print like 1 2 3 4 5 and 6 7 8 9 10. You see how the data is displayed as expected. Now we can have plot.figure. It will plot data series tall students in red using the first 2 elements of x and y. So plot.scatter x all rows second column and y all rows and second column, with S is equal to 100, color equal to red, and label is tall students. And plot the second data series short students in blue using the last three elements of x and y. So plot.scatter x starting from second position everything, and y starting from second position everything. S is equal to 100, color is equal to blue, label is short students. So short students and tall students. So add the label to the x-axis, plot.x label, the number of times the child kicked a ball, and add a label to the y-axis, the grades of the student, and we can add a title, plot.title, relationship between ball kicking and grades. And you see its information is added here, relationship between ball kicking and grades, and these are I think short students and tall students, and the number of times the child kicked a ball and the grade of the student. We can add a legend that use the label from plot.scatter with a plt.legend, and a legend should be added here, yes. So red are tall students and blue are short students. Add the legend to location 4, the lower right hand corner. Also get rid of the frames and adds a title. So plot.legend, location equal to 4, frame on is equal to false, title is equal to legend. And you see how the legends are here. Get children from current axis. The legend is the second to last item in this list. So plot.gca.getChildren, and you see these are the legend and relationship between ball kicking and grades and so on. Now get the legend from the current axis, plot.gca.getChildren -2. You can use getChildren to navigate through the child artist. So legend.getChildren 0, .getChildren 1, .getChildren 0, .getChildren. You see nothing is changed in this figure. It's just the extra information that we are extracting. Import the artist class from matplotlib. From matplotlib.artist, import artist. And we have a function recgc art, and depth is equal to 0. If is instance artist, increase the depth for pretty printing. So print depth plus string art for child in r.getChildren. Call this function again recursively, child and depth plus 2. Call this function on the legend artist to see what the legend is made up of. So you see, this is how the legend is designed. So the next one is line plots. We import NumPy as NP. We have a linear data np.array 1 2 3 4 5 6 7 8. We have exponential data, linear data to the power 2, and we plot.figure and plot the linear data and the exponential data. So plot.plot, linear data, marker O, exponential data, marker O. So linear data and exponential data. So we only give y-axis values, and the function was smart enough to understand the use index as the x-axis. The plot identifies this as two series of data, and the colors of the data from the series are different, including the data points and the lines between the data points. Now plot another series with a dashed red line. So plot.plot and this series with a dash red line, and you can see here. We can label it. So plot.xLabel some data, plot.ylabel some other data, plot.title a title, and age a legend with legend entries because we didn't have labels when we plotted the data series. So plot.legend, let's say baseline, competition, and for example yes. So this is how the legends are displayed. We can have fill between method. This is a greatest way to show, for instance, the standard deviation of result and error bars. So fill the area between the linear data and the exponential data. We can get plot.gca.fill between range, length of linear data, exponential data, face color equal to blue, alpha value is 0.25. So let's see how it has changed. You see, this is the standard deviation between the two values. So we have working with dates. We create a new image, plot.figure. We have a start date, end date, and date type. So observation dates, np.arrange, one date, end date, and date type. Plot.plot observation date, linear data, observation data, exponential data. So you see, this is how different dates are displayed, but these are not clearly visible. So this is unfortunately one of the great pain points in data science in Python: date time handling. The standard library does it in two different ways, while NumPy, which is used for scientific computing, does it a third way. In fact, there is probably a dozen replacement libraries for date times in Python. So let's try using pandas, which contain two date time. This specifically converts NumPy dates into standard library dates, which is what matplotlib is expecting. So we have import pandas spd, plot.figure, observation date as before, and observation date we convert pd.toTime observation dates. So we try to plot a map that will result in an error. Let's try to execute it. We have plot.plot, observation date, linear data, and observation dates. So, well, it's as expected. So the problem is the map function returns an iterator, and matplotlib cannot handle the iterator. So we need to convert it to a list. So list, map, and the rest is the same as before. Let's see. Still something more need to be done. So we get x plot.gca axis and rotate the tick label for the x-axis by 45 degree. Much better. So you see, this is easy to understand. These are different date, time, data. You can do some more decoration like this one, and like this one, and like this one, and you can see how the plot is changed. So units and dates and so on and so forth. So that's all for the plotting for today's lecture. We study up to line charts. In next lecture we will continue our discussion and we will study bar charts and dejunkifying the plot. So thank you.